Okay, here we go with our next one, and this one is dealing with readability, and we'll quickly cover order of operations and hit a recap. And yeah, so programs can have a long life and are meant to be maintained by multiple programs, in addition to the original author. For this reason, it's important to write programs that are highly readable. The main factor affecting this is going to be indentation. We're talking tabs, blank lines, spaces. These are things that are going to be ignored by the compiler. Don't worry too much about that word, as long as they don't appear in the middle of words or quoted strings. We're going to say this again. Effectively, let's replace this word with computer. All right, the computer isn't really going to pay attention to tabs, blank lines, and spaces as long as they don't appear in the middle of words. Specifically, we're talking about like reserved words or variables, or quoted strings, text. Okay, we've seen a little bit of both of this. So I'm going to basically demonstrate this with a readability experiment. Keep in mind this phrasing here. The compiler of the computer will ignore tabs, blank lines, and spaces as long as they don't appear in the middle of words or quoted strings. So the way that we're going to do our readability experiment is I have Hello World pulled up. And I actually think this is kind of fun. We just go through and add indentation, subtract indentation, and see what we can get away with. Right? For instance, here I have our class header, and I'm going to delete this space. And just simply going to ask, will this work? And as you can see right now, no, IntelliJ is mad at me. Right? If I try to run this thing, it's like, nah, man. I effectively took that word and it's no longer two words, it's one word. That's just not going to work. Public class together, this doesn't exist. This doesn't mean anything to Java. Right? So that space, that matters. Okay, but what if I got rid of this new line? What if we did this brace at the end here? Do you think that matters? IntelliJ looks pretty happy. I'm going to try running my program. And you see, hello world, we're perfectly fine, right? In fact, this is actually a little bit of a convention. Some programmers like this, right? And the real world of programming, it's kind of a 50-50 split. At least I like to think it's a 50-50 split on this convention. We call this end of line brace versus next line brace. Okay. In my particular class, I'll be using next line brace because that is what you typically see on some type of AP test. It is up to you, right? I don't care which one you use as long as you're consistent, right? Doing this, right here I have a next line brace, but here I'm using an end of line brace. I'm mixing my bracing convention up here. That's not recommended. I wouldn't do that. But what we're seeing is this indentation doesn't matter. In fact, and this is one of my favorites, we could just put everything on one line. I'm even going to get rid of the end of file line. Here is the entirety of Hello World on one line. IntelliJ doesn't look bad, but does it run? Yeah, it does. I'm going to tell it to execute Hello World. And I think this should really hammer in the point. Would you call this code highly readable? No. Like, to me, a human, to you, a human, I can't. This is a mess. To the computer, it doesn't care. We could even come in a little bit harder on these spaces, right? And get rid of some of these spaces. The computer does not care. Indentation is there for you. The computer, we can put everything on one line. Side note, if you ever hear the media talk about code and they're like, oh, the F-32 fighter jet has 12 million lines of code. And they're trying to talk about how complicated it is. Lines of code is a terrible measure of code complexity because I can put it on one line of code. I can take their 12 million lines of code and it's just one long thing. What does that matter? Let's back this up. So we're going to try to create highly readable code by using spaces that kind of help with that. And that indentation doesn't matter as long as it doesn't appear in the middle of text, quoted text, which is going to be this thing, or the middle of words, right? So if I came in here with hello world and I try to put a space, it doesn't like that. Effectively, I have a space, some indentation that's appearing in the middle of a word. In this case, the name of the class header. Okay, but what I can do is like in the middle here, right here, I have a space, but realities are this could be like lots of spaces. Right here I'm using tab. Again, IntelliJ's not mad. If I tell it to run, we're going to get our hello world result. Perfectly fine. This indentation exists for you. We could, in theory, space this out over multiple lines, right? Instead of spaces or tabs, it's new lines. Again, it's about trying to create code that you like. That's not a typical convention, but it's possible. One that's tricky is down here, right? I have my system.out.println command. And our slide said, as long as it's not in the middle of words or quoted strings. Okay, well, what about right here, like where my cursor is at? I'm hovering around this period. We call it the dot operator or the method selector. That's not important. I'm right here next to this period. And my question is, what if I put spacing there? Am I in the middle of a word? Not exactly. I would say not exactly. Is it quoted text? Let's just try it. I'm going to throw in a tab, and we see that actually does not make it mad. So this would not be considered the middle of a word. I find that a little interesting, right? And then likewise over here, maybe you could put a space there or a tab there, and that's perfectly fine. We're not in the middle of a word. But if I try to maybe take my print line and separate the print from the ln, yes, that word is no longer what it was. It now contains a space, and that's ruining it. Okay, the last thing I'll kind of talk about here in terms of readability is this quoted text thing. Here I actually have some quoted text, hello world. And what our slide says, the compiler, the computer, will ignore it as long as it doesn't appear in the middle of words or quoted strings, quoted text. What that means is text that is, spacing, indentation that appears here in the middle of this quoted text, this string, does affect my program. What do I mean? I throw all these spaces in here. Well, space is actually a character. It's inside of this quote, so it's not going to be ignored in my program. What do I mean? If I run it, all those spaces, they show up. They show up in my output. That's what that means. Okay? So I kind of invite you to poke around and play inside of this, adding indentation in really weird spots and see how it affects your program. I would argue, right, keep in mind that this spacing is for you. Something like this, it's possible, right? It's lacking in indentation. The compiler, the computer, doesn't really care. It still runs, but it is not highly readable. I have had one student in my teaching career that they tried to turn in code like this consistently. It's not highly readable, right? The indentation really helps us see that these statements are inside of our inner bodies. Okay, again, poke around, play, add some indentation, see what works, see what does not. Okay, so that's been readability. Let's talk next, let's switch topics very fast, order of operations. Switching gears, arithmetic expressions in Java look and evaluate just like they would ones you've already encountered, like algebraic ones, right? These expressions are composed of operands. We don't see this word a lot when we're dealing with this stuff in algebra, but here I'm going to kind of talk about it. Operands, these could be values or variables, as well as operators, right? Plus, minus. We got this asterisk. I think you can figure out what that is, multiplication. This is going to be our division bar, and then this thing, we'll talk about at a later date. These are operators that can combine to make more and more complex expressions. So we have addition, subtraction. This is our multiplication symbol. This is our division. This is / by the way. It's leaning forward as opposed to backslash. I'll quickly show you a backslash. Right? This is a backslash. This is a / I invite you to look for those on your keyboard. Okay, the / is our division symbol, and modulus we'll talk about at a later date. So in order to properly evaluate these expressions, smaller sub-expressions will be evaluated first, depending on operator precedence. This is known as the order of operations. Here is our order of operations. Parentheses first, exponents, multiplication and division share a precedence level, and then addition and subtraction share a precedence level. Note operators with equal precedence. Interesting. These slides have been through 7 years of teaching, and no one's ever caught that. Operators with equal precedence will be evaluated as they appear in the expression from left to right. What do I mean? Multiplication and division, they have equal precedence. So as we go from left to right, whichever comes first is what we'll evaluate. Same thing with addition and subtraction. I think most of you know this, but we see these letters are highlighted, this PEMDAS. When I was growing up, we used the "Please excuse my dear Aunt Sally" as a way, mnemonic to remember these things. Okay, so try this out. Pause the video, grab some paper, pencil, and evaluate these things. I'm going to ask you, what do we evaluate first? Right, there's several operators. /, that's division, plus sign for addition. We got this asterisk indicating multiplication. And there's also operands. We have 8, 4, 3 squared is one operand, 2. All right, these are all values that are being performed on. So what we're going to evaluate first is our parentheses. And inside the parentheses, we have an exponent. That is our highest precedence, right? Parentheses. So I've located the parentheses. There's an exponent there. So I'm going to execute the exponent, right? 3 squared, that's 9. This is still inside the parentheses, so we'll then multiply that by 2, giving us 18. And then I'm done with the parentheses. Okay? And we got division and addition. The division has higher precedence, so we'll do that. 8 divided by 4 gives me 2, so we got 2 plus, or what do we say over here? 18. Normally I would write on this slide on the screen. Okay, to try this one, I'll give you an answer somewhere. I don't know. So you can also try some of these, and I believe I'll post the answers to these somewhere. But that's honestly order of operations. It's what you're used to. But we're going to end up, we see these symbols, right? These symbols are what we're going to use in Java in order to evaluate these things. So it's a matter of taking these expressions and then kind of translating them into Java code, which is where we're headed. But in order to properly evaluate them, you need to know order of operations. And duh, it's what we would encounter in algebra. Let's recap. The main factor affecting a program's readability is indentation. What is indentation? We're talking, maybe that's the next question. Nope. Indentation. We're talking tabs, spaces, new lines. All of that counts as indentation. These are things that are just there for you. The compiler doesn't care about them unless they appear where? The Java compiler, essentially the computer, will ignore indentation as long as it doesn't appear in blank or blank. We're talking the middle of words or quoted text. Quoted text, it said strings on my other slide. Those are effectively the same thing. Which of the following operator has the highest precedence? Exponents. Which of the following operators has the highest precedence? Parentheses. Which of the following operators has highest precedence? Kind of a trick question here. Division and multiplication share a precedence level and thus will be evaluated from left to right. All right, that's it for readability and order of operations.